these different configurations. There's two charges. Okay, they have the same magnitude of charge, but sometimes one's positive, sometimes one's negative, sometimes they're both positive, sometimes they're both negative. You have to look at the drawing. And then we are interested in the location marked with an X point or and a P, which is not one of the two charges. So there's two charges and then this third location that we're interested in. Okay. The force, if we stuck a charge at point P, how would the force compare? How about A? What's the force on a charge stuck at point P? 0. Because if it's a positive charge, it's attracted to the charge on the left, and it's attracted to the charge on the right equally because they're the same Q and the distances are the same. So those two forces would cancel out, right? Force is a vector quantity. Force to the left and a force to the right cancel each other out. How about the next one? What direction is this force? Let's pretend our charge that we're putting at point P is positive. Did they ask us? Did they tell us? Let's take a look. We've got two forces acting on it, right? We've got a force from the positive charge that's going to repel the positive charge we stick at point P. So it's going to the right. I'll call that F positive. And it's relatively small because the positive charge is twice as far away as the negative charge, right? So it's going to have 1/4 the force. You see that? And we've got a negative charge there, and it's going to be an attractive force. And so since the magnitude of the negative force is greater than the other one, it wins, right? You're going to do vector addition, and you're going to end up with a small force to the left. Okay? Let's just figure it out. What is it? Let's put the charge, let's say they're all charge Q. Q, Q, Q. So it's KQ squared over two R squared in the positive direction, right? And in the negative direction, it's KQ squared over R squared. So we're going to get a negative 3/4, where x hat is to the right. So it's to the left. And the value is 3/4 of if it was sitting right next to it, right? Okay, how about point C? What do you expect the force to be there? What direction? Magnitude? To the left, because if there's a force acting on this one from the positive to the left, those repel each other. There's also a force acting on it from the negative, because those two attract each other. So you add them together. So it's twice the force from a single charge. Okay, so how do these rank then? And then we have, what do we have? B and G. Is that right? And then D and E. And then C, is that right? Gesundheit. Let's do D. D has positive, positive, and there's our point P. So the force, we're going to have a big force and a smaller force, right? So we'll add those two together. And we get 5/4. So one of them is producing a force that's 1/4 of the other one, but we're adding them together. So we get 1 1/4 times the single force. I think that works out to this ranking, doesn't it?